So it's very technical, and the user interface is sort of not streamlined. How many of you have used TrueCrypt for disk encryption? Okay. How many of you, without using the manual or reading the introduction, after the installation, knew what to do to encrypt the disk? All right, see? So significantly less. Now expect if I ask the same sort of question in an audience where I was introducing this TrueCrypt as a corporate full disk encryption solution. People will be just confused. So Descriptor is another open source project that implements the TrueCrypt specifications. It was created by some Russian guys, and it's still in development. The current version is 0.4, and as I said, it implements the TrueCrypt specifications, so it's TrueCrypt compatible. You can use Descriptor to encrypt your disk, and then use some TrueCrypt recovery tool later on to, to open your disk if you have the password to do whatever recovery work you need to do. Sadly, and this is one big point, Descriptor decided to go away from the TrueCrypt compatibility for some reasons that I don't understand. Or I do understand, but I don't agree with. They just make it a little bit easier on themselves, so TrueCrypt won't be compatible anymore. It's also unsuitable for enterprise environments because it also doesn't have key management, because that's just lacking in the TrueCrypt specifications. There's no user management, and it has no installer application. So if you want to use Descriptor from the project website, you have to take the system driver, you have to copy it pretty much to where you need it to. You need to run some commands to set it up, and it's just, hackers can do it, but no one else, pretty much. So this is pretty much the reason why I got involved, and I created a little derivative. Right now it's called +AC, based on Descriptor. And the one point, it includes an installer and uninstaller. So you're guided through the installation to the point where you say, which drive do you want to encrypt? What's your password you want to use? Okay, let me go encrypt the disk, and you can give this your mother and she'll know what to do. We've also written some manuals, so that might be of some help for some. But because Descriptor itself decided to go away from TrueCrypt, we'll probably fork this under a new name. Descriptor +AC isn't really that sexy of a name, so we'll see where this goes. I've talked about the TrueCrypt specifications, and here's a little more detail about this. So there's a volume header. When you have your disk drive and you want to encrypt it, there's a header somewhere that gives the software, when it starts up, all the information that's needed to start up. So this header information for most cryptographic or for most full disk encryption products is usually in the open, so you can look at it. In terms of, like, if you look at on the disk, you can see the bits. If you know how to make sense of them, you can read them. TrueCrypt is sort of different, as in it has this volume header also encrypted. And it's stored in place in the system partition, and it's 512 bytes in size, and we'll see in a minute why this is important. So as I said, the header is encrypted. There is a magic string, true, which is also encrypted, and if you provide your password to TrueCrypt on boot to the pre-boot environment, then it tries to decrypt the header, and if it does find then the magic string true upon decryption, then it knows that the key is right with a fairly high probability and goes on. For TrueCrypt, you can also use file-based volumes. So these are files that are then opened and made to look like a disk. And these have additional headers. And they're significantly bigger because they implement other stuff. There's a backup header, which is also not present when you encrypt the disk with TrueCrypt. The interesting part here is that the encryption key for this backup header is derived from a different salt. So if there's something wrong with the front end, the first sector, then you can also always go back to the backup header and use it. Again, omitted for in-place encryption. So if you look at a disk, you have the sector 0 over here. Let's just call this the first sector, which is your MBR, your master boot record. It contains the stuff needed to boot, to initially boot the system, and partition table and everything else. Then for some historic reasons, there's a couple of sectors that are unused. And then there's the operating system. And maybe you have a second partition that starts at some sector X and goes to the end of this system, and it's an unused system, unused partition. And this would be the setup you would have to have for TrueCrypt to use hidden volume. What you do is you install TrueCrypt, tell it to install to encrypt the system. For a hidden operating system, what it does is it encrypts your system. It uses this partition, encrypts it, and you're supposed to put some decoy data on here. And then in the last step, it creates a little hidden segment in here, which is your hidden operating system. So with this feature, you can provide password A to the boot environment, and this operating system starts, and you'll see this data. You provided password B, and this operating system starts right here, and you see this data. And the operating system, the TrueCrypt driver, actually implements all the logic so that when you run this operating system right here to the system, it looks like it's running from the first partition. So Windows doesn't know anything, well, major Windows doesn't know anything about the encryption at that point either. So another interesting part is the in-place encryption. So again, the start-out layout. You install TrueCrypt. What it does is it allows you to encrypt the first partition, because every byte you encrypt on a hard disk takes up that amount of bytes on in encrypted form. So you don't win or lose any data, sort of, in terms of like what size it is. So if this is your file system, you encrypt it, you use that same amount of size, but you need to store the TrueCrypt header somewhere, and TrueCrypt actually prepends it to the before the partition. So because there's some unused space over here, it can do it here, but with the second partition, there's no unused space in here, so it cannot convert the second partition on the fly because it doesn't have any room for the header. If you have, for whatever reason, some extra space in here, if your partition 1 ends, then there's some slack, and then your partition 2 starts, then you could also encrypt the second partition. Although I don't really know if TrueCrypt would really identify that and work correctly. Descriptor is a little bit different in that respect. It actually shrinks the file system a little bit and places the TrueCrypt header inside the partition. So I would argue it's even a little bit more compliant with the TrueCrypt specifications than TrueCrypt itself. So what it does is it inserts the header here and then pretty much shifts every block back one when it's being encrypted. So the encryption driver from TrueCrypt knows if it's encrypted, it needs to shift it over. If it's not being encrypted yet, it knows this is the place where I start from. And this is also the reason why Descriptor encrypts the disk in the initial encryption from the back to the front. And the benefit is you can have a second encrypted partition on there. My last point is open source feature wish list. Of course, TrueCrypt compatible user and key management. So I would like to see TrueCrypt, the body, TrueCrypt, the organization, address this this lack of feature at some point, and maybe they can do it by extending the current specifications, or they just add on some other specifications that allow you to lay off your user and key management data outside of the actual TrueCrypt header. So that way you could stay backwards compatible and also allow for user and key management to take place. Pre-boot authentication. I would like to see some additional implementation where the pre-boot authentication environment is stored. Right now, it might be stored in some slack space on the disk, like the unused sectors up front. There's other ways you can think about it. Maybe you put it in some hidden sectors on the disk, or you maintain the pre-boot authentication environment in a file that's as the only piece of information on a disk is not being encrypted. Cryptographic key storage, TPM support, high security modules, network booting, so anything that's interesting to push the key out of the system, but to allow automation like for a server environment. Protection against cold boot attacks. I would say this is because I'm running down low on time. Well, so cold boot attacks pretty much you're vulnerable to now. There are ways that you could theoretically right now protect against it by keeping the key material not in memory but inside the CPU, make it thus harder to get to. Cache lines, specific registers that if you can get your operating system to not otherwise use these registers may be a point. I/O ports, maybe. Makes it slow, but could be an approach. So there's various ways that can be looked at, and I would like to see some effort made in that direction. So there's a workshop tomorrow from 7 until 8 in A3. I believe the room holds about 20, 30 people maybe. So if you're interested, show up early, and there's no agenda just yet. I'm willing to work with you on whatever sort of topic or questions you have. So this is it. Thank you for your attention.
Although there's maybe a wish list of free software, open source software, do you really think it's a good idea to use or to recommend to customers cryptographic systems or products that are closed source or proprietary? Because you have even not a chance to prove whether there are proof or whether there's a backdoor.
Right. So that's if the open source community can add enterprise support to these projects, whether TrueCrypt, Descrypt, or whatever else, then you have a foot in the door that that corporations will gladly take. Right now, it's just not acceptable to them.
I am just taking the opportunity to make a question to the audience. It's because I have an older hard disk with loop IIS encrypted, and I forgot a part of the passphrase. So if by chance anyone, I mean I have the most part of it for sure, but if by chance someone wants to try a hack on it, then please talk to me. Thanks.
All right. All right. I have also one more, since I forgot about the additional questions. Where's the guy in the back that raised his hand? Is that you? Did you raise your hand? There you go.
Thank you.
You're welcome.
Maybe I have one question. I mean, TrueCrypt is free software and open source software.
Right.
So basically I can look inside the source code.
Right.
But since I'm not able to understand what is inside the source code, who can tell me is it really safe? And I heard that some security experts like Bruce Schneier, etc., had a look into the source code and said, well, it's a pretty mess. So what's your opinion about that?
I said earlier that I have some issues with the TrueCrypt internals. And this is my point, is their source code is C++ and assembly. And while C++ is an interesting language, it's not really a good choice for that sort of environment. And they have just issues in their source code. Without me being able to say, okay, this is wrong,